Alright, this is Mr. Gillum, and today we're going to start some triangle constructions. So, not that we're actually going to be constructing triangles, but important parts of the triangle can be found through constructions. So, the first thing we're going to learn today is how to construct a perpendicular bisector, and that's going to lead us into some theorems. Alright, a perpendicular bisector means exactly like it sounds. It is a perpendicular line that cuts a segment right in half. Okay, where it intersects is the midpoint. All right, so the distance of A to let's call this M to the midpoint is the same as the distance from M to B. It has to cut it right in half, so bisects into two equal parts. Okay. Another special thing about the perpendicular bisector is that if any point that I pick on the perpendicular bisector, its distance from A and B will be the same. Okay. These segment lengths are congruent. This guy and this guy, this guy, and this guy. It doesn't matter where I go as long as I'm on the perpendicular bisector, and it will be the same distance from each endpoint. Okay, one of those qualities that you may not have realized, but actually happens. Okay, so like I said, it doesn't matter where I have the point at. If it's right here, those two are equal. If it's right here, those two are equal. Okay, there's always equal length from the perpendicular bisector to each endpoint. All right, now this guy is not me doing this, so I'm going to narrate for you because you can't really hear him. So what he's doing is he's taking his compass and he's trying to find the perpendicular bisector of this line. This one, I shouldn't say line, I should say segment. And so he's going to town and he's opening. It appears he's just making sure that his compass must be at least half of the length of the segment AB. So he needs to make sure that it's at least halfway from B to A before he makes his arc. All right, so if I were writing the steps for myself, I would say first things first, I need to open the compass a length that is at least half of the segment length. Okay, so open the compass wider than half the segment length. And then make your first arc by putting your point on one end and making your arc. And then you're going to take your compass and you're going to put it on the other point of your segment and you're going to make another arc. Now, once you've made your two arcs, really you're only concerned with where the arcs cross. Where the arcs cross right here, this little guy right there, that little spot and that little spot. If you can connect those 2 points, then you are guaranteed a perpendicular bisector to your segment. All right, so this guy's getting all fancy and stuff, and he's grabbing his ruler, but honestly, we don't really need to watch much more of this. He's just going to make his straight edge. He's going to put a straight edge on there, and he's going to just connect the points. And that's really it. You're just going to open your compass more than halfway, make your arc on each side, and connect the intersection of the arcs. Okay, and he's a little slow poke. But as you can see, it makes almost a perfect right angle right there. And actually it should be perfect. And then this segment will be the same as this segment, and that'll be it. Okay, so that's how you construct a perpendicular bisector. A lot of times you put the letter M right there for the midpoint, like he did. And that guarantees you that you're both halfway in between A and B, and any point on this line will be the same distance from A and B. All right, that's enough of that. The converse of a perpendicular bisector is this. Remember when we flip the if then around? You also know if any point is equidistant from the endpoints of a segment, then it is a perpendicular bisector. So this is kind of like those proving parallel lines theorems. Basically, you can work it backwards as well. All right. Perpendicular bisector theorem says if you have a perpendicular bisector, this guy is the same distance from each line of the segment. Now we're saying if any point on the segment is the same distance from A and B, then this line must be a perpendicular bisector. All right, now we're going to use this and apply this in our proofs and theorems, but right now, those are the qualities you need to know. Okay, you need to know how to construct a perpendicular bisector. You need to know that every point on the perpendicular bisector is the same distance from the endpoints. It is a 90-degree angle, and the segment length is exactly the same on both sides. All right, and it works forwards and backwards. Once again, this is another one with the converse. Okay, so depending on what you're trying to prove, if you're trying to prove something that's perpendicular, then you can use this for that. If you're trying to prove that something is, you're trying to prove that it is a perpendicular bisector, you could also do it that way as well. But that's it for today, and hopefully you can construct, I know there's only one example, but you can construct a perpendicular bisector, and we're going to do some practice in class on that. So that's it.